Welcome to the deep dive. We're here to cut through all the buzz and the noise around things like AI, RA, agentic systems,
Yeah,
all that stuff.
yeah, there's a lot out there.
Exactly. And if you're trying to navigate all this complexity, maybe wondering, okay, what's the smart way, the strategic way to get RAG really working well, then you're definitely in the right place.
Totally. The jargon alone can make your head spin, right? RA is dead. Agents are the future. It's hard to know what's what.
Uh-huh.
So our mission today really is to give you a clear framework, plain English, something you can actually use to, seriously improve your RAG systems.
So we're drawing on some serious experience here, right?
Yeah.
Folks who are actually building Google search, now doing work at Pi Labs.
That's right. This isn't just theory. It's wisdom from the trenches, you could say. Battle-tested stuff.
Love it. So we want to help you understand why certain techniques actually matter, not just that they exist, and crucially, when to use them strategically.
Uh-huh.
How to, shore up the quality of whatever information retrieval system you're dealing with.
Exactly. We'll unpack a whole range of techniques from like the super simple starting points all the way up to the really advanced strategies.
But in this feels key, we're focusing on applying them based on what's actually broken in your system, not
Yeah.
just chasing the latest trend you saw on, I don't know, X or LinkedIn.
Precisely. Think of this as maybe a shortcut, a way to get genuinely informed about optimizing RAG in a practical way.
Okay, let's dive in. Where do we start? You mentioned a foundational principle, quality engineering.
Yeah, quality engineering first. It's so tempting to jump straight into the tech debates, should I use BM25 or vector search? But honestly, that's usually the wrong place to begin.
Okay, so where should we begin?
Start with the outcomes. Always. What's the actual product problem you're trying to solve for your users? What does success look like?
Right, not the tool, but the job you want the tool to do.
Yeah.
Makes sense. How do you measure that effectively, though?
Well, that brings us to what we call the quality engineering loop. It's a structured process, almost scientific, really.
Okay.
First step, define your quality bar, or maybe a launch metric. What does good enough or great actually mean for this system?
Got it. A clear target.
Then you set up query sets. Think of these as benchmarks, easy ones, medium ones, really hard ones that represent how people will actually use your system.
So like stress tests designed around real-world scenarios.
Exactly. Rigorous test cases. Once you have those, you baseline your current quality. See how you perform right now against those benchmarks.
Okay, measure where you stand.
Then comes the critical part, loss analysis. You dig into the results and figure out what's actually broken. Where is the system failing on those queries? Which types of queries? Why?
So you diagnose the specific problem first.
Yes. Only after you've done that thorough diagnosis should you even start thinking about applying specific techniques or solutions.
That's actually really profound. Don't just throw tech at it until you know exactly what needs fixing. The links to that other idea you mentioned, right? Complexity-adjusted impact, or stay lazy.
Haha, yeah. Stay lazy. It's maybe a bit provocative, but it's the core philosophy. Only fix what's broken, and importantly, start with the fixes that give you the biggest bang for the least buck, basically.
Okay. Least effort, biggest gain.
Exactly. Techniques vary wildly in difficulty and impact. Prioritize the easy stuff that gives you, quite a bit of quality improvement first.
Yeah.
BM25 is often a great example. Pretty simple to try, often works decently well.
Right.
Don't spend months building custom embeddings if your problem space isn't super specialized, and standard relevance is mostly okay, Be principled. Avoid that temptation to over-engineer.
Work smarter, not harder. Strategic laziness. I like it.
That's the idea.
Okay, fantastic foundation. But let's start peeling back the layers of techniques then. Tier 1. Starting simple, what's this in-memory retrieval? Sounds basic.
It is. It's the absolute simplest starting point. Low effort. You basically just take all your documents and shove them straight into the LLM's context window.
Okay. So you're just relying on the LLM's big context window, like in something like Notebook LM.
Exactly. You upload a few docs, ask questions, no fancy Arbor setup needed initially.
Okay, that sounds
Yeah.
almost too easy. Where does that approach start to break down?
Well, it hits limits pretty fast. Your queries get too long, or you have too many documents and things just don't fit in the context window anymore.
Right.
Or sometimes even if they fit, the LLM just doesn't pay attention properly to all the documents you gave it. It might miss stuff.
I see. So if your loss analysis starts showing, context limits being hit or the LLM ignoring key docs, That's your cue.
That's your cue. Time to move to the next tier.
And that next logical step is often term-based retrieval, right? Like the BM25 you mentioned.
Exactly. BM25, it's a classic keyword-based search algorithm. Still remarkably effective, very easy to try out, and honestly works pretty well for a lot of things.
How does it actually work in simple terms?
Well, it looks at the terms in your query, obviously,
Yeah.
but it's cleverer than just counting words. It considers like how often a term appears in a specific document, how long the document is overall, and crucially, how rare that term is across all your documents.
Ah, so it gives more weight to unusual words. If I search striped hummingbird moth, it knows striped and moth are common, but hummingbird in that context is rarer, so that gets boosted.
Precisely. It's finding that unique fingerprint. It's good at that keyword style matching.
But where does it start to fall down? When does BM25 simplicity become a problem?
It struggles when things don't really have that keyword nature. If your query is more conceptual, more semantic, asking about a general idea rather than specific terms.
Just how do I make my team more innovative rather than innovation techniques PDF?
Exactly. BM25 might miss the mark there because the exact keywords aren't necessarily in the best documents. And that brings us nicely to Tier 2.
Right. Tier 2, adding nuance. We're talking relevance embeddings, vector search, and re-rankers. So when do we really need to jump into vector search?
You typically need relevance embeddings, vector search, when you've moved beyond simple keywords. You need to handle more nuance, more semantic meaning. Instead of just matching words, you create these numerical representations vectors for both the query and the documents. Then you measure the distance or similarity between these vectors in vector space.
Can you give a concrete example? Like, when is it absolutely essential?
Sure. Think about asking ChatGPT or a similar system. If you ask iPhone battery life, well, that's pretty keyword heavy. BM25 might do okay.
Right.
But if you ask how long does an iPhone usually last before I have to plug it in again, that's semantic. There aren't obvious keywords there that guarantee the right answer. You need something that understands the meaning.
Gotcha. It understands the intent behind the phrase, not just the literal words. Very cool. But I'm guessing vector search isn't perfect either. What are its limitations?
No, definitely not perfect. It can actually struggle sometimes with precise, exact keyword matching, which is exactly where BM25 shines.
So they're complementary, really.
Very much so. And often the best approach uses both. But when you combine them, you sometimes get this conflicted candidates set. Documents that both systems think are relevant, maybe for different reasons. It gets messy.
Okay, and that's where re-rankers come into play, to sort out that mess.
Exactly. Re-rankers, especially the ones called cross-encoders, are designed to resolve those conflicts. They're more sophisticated.
So?
Well, standard vector search compares a query vector to document vectors separately. A cross-encoder takes both the query and a document together as input and gives you a single relevance score. It attends to both at the same time.
Wow, okay. So it gets a much deeper look at how well that specific document answers that specific query.
Precisely. Much more powerful for fine-grained relevance judgments.
What's the catch? There's always a catch.
Yeah, the catch is they're computationally expensive, like really expensive compared to the initial retrieval. So you can't just run them on your entire document collection. The standard pattern is use BM25 and/or vector search to get a larger set of, say, 100 candidates.
The initial pool.
Right, and then you use the expensive, powerful re-ranker on just that smaller set to get your finally ordered top 10 or 20 results.
Makes sense. Use the heavy machinery only where it's most needed. But you said even re-rankers have limits. Still mostly semantic similarity.
Yeah, they're still primarily focused on how similar the meaning is. And relevance isn't always the whole story, which leads us beautifully into Tier 3.
Tier 3. The true deep dive. Going beyond pure relevance. Okay, I'm intrigued. What are custom embeddings for domain specificity?
Right, so this is super important when you're dealing with highly specialized areas. Think legal, medical, maybe very specific engineering fields.
Okay.
Standard embeddings trained on, like, the whole internet just won't understand the nuances. We saw this in the source material with legal terms, right? Where it's like regime, material, moot.
Yeah, they have very specific meanings in law that are totally different from everyday usage.
Exactly. A general model will completely miss that. It's like the vocabulary is just out of distribution for that general model. It doesn't know the local language, so to speak.
So the trigger for considering this is when your loss analysis keeps showing failures because the language itself is unique to your domain.
That's the absolute key decision point.
Hmm.
If your system keeps misunderstanding queries because of specialized vocabulary, then you start thinking about modeling your own domain in its own vector space, creating custom embeddings.
Got it. Solve the problem you actually have.
Don't do it just because it sounds fancy. Do it because the data tells you it's necessary.
Right. And beyond custom language understanding, you made a really interesting point. Relevance is not ranking.
Well,
What else goes into ranking, like in Google search, that isn't just about semantic match?
oh, this is huge.
Yeah.
And often missed. Relevance is just one signal. Google looks at tons of other things. Take price signals, for example. Yeah, the source mentioned this great example. Querying Perplexity for cheap gifts for my son. Okay, simple enough. But then following up with, but I have a budget of $50 or more.
Okay.
And it still showed stuff under $50. It understood cheap semantically, but it completely missed integrating the price signal, the $50 or more constraint, into the actual ranking of results.
Wow. So the relevance part worked, but the ranking logic failed because it didn't incorporate that structured data point correctly.
Exactly. And there are tons of others. Think merchant signals for e-commerce is the seller reliable? Or for podcasts, maybe listen counts. How popular is this episode? Even PageRank, Google's original secret sauce.
Yeah.
That's about the structure of the web, link counts, not the semantic content of the pages. It's about prominence, authority derived from connections. These are all vital ranking signals that have little to do with pure semantic similarity.
Okay, so this sounds like a distinction between maybe horizontal semantics, general language understanding, and vertical semantics, this deep domain-specific knowledge, plus structured data signals.
That's a perfect way to put it. In these vertical domains like a CRM, internal knowledge bases, specialized databases, that general natural language relevance is often only a tiny, tiny fraction of the whole semantic picture. If you only focus on improving that general relevance, you'll hit a ceiling fast. If you're not also bringing in these other crucial domain-specific signals, structured data, relationships, all that stuff.
It's like needing the specialist dictionary and the user manual,
Yeah.
not just the general dictionary.
Exactly.
Okay, so custom domain embeddings, integrating structured signals, that feels pretty comprehensive. But you're saying even that isn't always enough. Things can still go wrong.
Oh, absolutely. Because even with perfect domain understanding and all your structured data, there's one final chaotic element.
Users.
People.
People. User behavior can still completely mess up your beautiful ranking. They click on things you didn't expect. They ignore the thing you thought was the perfect answer.
So what's the answer then? How do you account for,
Oh.
well, us?
You have to integrate user preference signals. This means tracking things like clicks, obviously, what do people actually choose, but also explicit feedback like thumbs up or thumbs down ratings.
Okay, that sounds complex, weaving that into everything else.
It is complex, yeah. You're starting to build prediction models, maybe predicting click-through rates, and then you have to create what's called a balanced ranking function.
Balanced. Yeah.
Yeah, one that intelligently combines everything. The content relevance, those structured vertical signals we talked about, and these dynamic user preferences.
Yeah.
It's a whole other level of sophistication.
Wow, okay, so we've layered retrieval, relevance, domain specifics, structured data, user behavior. What's next? What about actually running the system efficiently?
Yeah.
That brings us to Tier 4, advanced orchestration and optimization. Let's start with orchestration or fan out. What's that about?
Right. So sometimes the problem isn't just the search results, it's the query the LLM sends to the search system in the first place. LLMs can generate kind of wrong queries for search engines.
How so?
There's often an impedance mismatch, is the term sometimes used. The LLM doesn't really know your specific search backend. It doesn't know its quirks, what kind of queries work best, what data is indexed how.
Ah, okay.
What?
It's making assumptions that might be wrong for your specific search tool.
Exactly. So the solution is often to take more control of the actual orchestration. Instead of letting the LLM fire off one big, potentially flawed query,
Yeah.
you break the user's complex requests down into maybe, in smaller queries, multiple simpler queries that you then fan out, send them off, maybe in parallel to targeted parts of your search system or different systems.
Kind of like that Google AI overview example.
Right.
They're making like 15 or 20 subqueries behind the scenes for one user question.
Precisely that pattern. The LLM might try to do this, but often you, the system builder, know your backend best. You need to orchestrate it more directly because, frankly, the quality isn't quite there yet for agents to just figure out complex search orchestration reliably on their own across diverse backends.
Got it. take control when the LLM doesn't know enough about the specifics. What about supplementary retrieval?
This one's refreshingly simple, actually. It just means search more.
Search more.
Yeah. Basically, increase your recall. Retrieve more candidate documents up front. Don't be too skimpy with your initial retrieval step unless cost is an absolute overwhelming constraint.
Why? What does that help with?
It helps tremendously with ambiguous user intent. Remember that Middle Eastern dish example that apparently stumped even Google?
Uh-huh.
The query is vague. To really understand what the user might want, you might need to reach out to a lot of backends. Maybe check restaurant databases, look for recipes, search images, related concepts. You need a wider net.
So casting a wider net initially gives you more puzzle pieces to figure out what the user really meant.
Exactly. More context, more potential signals, better chance of satisfying that ambiguous intent.
Okay. And the last piece in this tier, distillation. When does that come in?
Distillation is really about optimization, usually for cost and latency, especially when you hit serious scale, like your GPUs are melting and response time is becoming a real problem.
Right. Things are getting slow and expensive.
So instead of using a massive general-purpose LLM, which might be overqualified for a specific task within your RAID pipeline, you fine-tune smaller, cheaper, faster models to do just one thing really well.
Like training a small model just to handle query classification, or another just for answer summarization.
Precisely. Perplexity was mentioned as an example of being really fast at question answering. That speed likely comes from using highly optimized, distilled models trained specifically for that task, not just throwing the query at GPT-4 every time.
Okay. But that sounds hard, like really hard.
Oh, it is. It's a very advanced technique. You only really go down that road if your loss analysis is screaming that latency is killing you. Like, if a 10-second wait is causing users to leave but a 2-second response keeps them happy, then the pain of distillation might be worth it.
Only if the performance bottleneck is genuinely hurting the user experience and business goals.
Exactly. Don't optimize prematurely. Fix the quality first, then worry about hyper-optimization if needed.
Okay. We've covered a ton of engineering layers, but you mentioned an ultimate layer, when engineering kind of hits its limit.
Yeah, because let's be honest, quality engineering in these systems, it's never going to be 100%. Perfect is impossible.
Yeah.
These are stochastic systems, right? There's inherent randomness.
Things will still go wrong sometimes, no matter how good the engineering is.
Exactly. So when you've tried all the engineering fixes and you still have edge cases or problems you can't quite crack, what do?
You punt the problem upwards, as you said, to product design.
That's the running joke, but it's deeply true. Often the best answer isn't another algorithm, it's in the design of the product itself, how the user interacts with the system.
Okay, like UX design.
Absolutely. Think about a customer support bot. If it gets totally stuck on a complex issue, good design means it doesn't just keep failing. It gracefully says, okay, I need to hand you off to a human agent. That's a design solution, the human in the loop.
Right. Managing the failure case through the interface. The Google Shopping UI example was great too.
Yeah, that really illustrates it. When Google Shopping has high confidence, lots of structured data, reviews, etc., it shows you a really high promise UI. Filters, comparisons, lots of detail.
You trust it more.
Right. But when its understanding is lower, maybe it only found some general web documents about a product. It doesn't pretend it knows everything. It degrades the experience gracefully.
How so?
It might just show you, say, 10 Lou links or 10 product image options. It essentially says, here's what I could find. It might be relevant. You choose. It's still workable, still useful, but it adjusts the UI based on the system's actual confidence level.
That's really smart. Managing user expectations through the interface itself, acknowledging the system isn't perfect.
Exactly. And that really brings us back to the core message that underpins this whole framework. Maintain an empirical mindset.
Test, measure, analyze.
Everything is empirical. Forget the theoretical arguments, context windows versus RAG, agents versus whatever. None of that matters as much as your actual data.
Right.
Constantly baseline your system. Rigorously analyze those losses. Where is it failing for your users on your data? And then choose the techniques, layering them in based on what's actually broken. Be principled. It saves so much time and effort.
Okay, so let's try and recap this whole deep dive. We started by pushing past the buzzwords, really emphasizing that why, the outcome, the quality engineering loop before getting into the how.
Right, diagnosis before prescription.
Then we went through the tiers.
Yeah.
Tier 1, simple stuff, in memory, basic term-based like BM25.
Easy wins first.
Tier 2, adding nuance with relevance embeddings,
Yeah.
vector search for semantic meaning, and re-rankers like cross-encoders to refine results.
Getting more sophisticated.
Tier 3, the really deep dive. Custom embeddings for unique domain language, and crucially, integrating signals beyond just relevance, price, popularity, structure, user clicks. Because relevance isn't the whole ranking story.
Yeah, that vertical semantics piece is huge.
Tier 4, advanced orchestration, fanning out queries when the LLM struggles, and optimization like supplementary retrieval, just search more,
Yeah.
and distillation for cost latency at scale.
Controlling the process and making it efficient.
And finally, the ultimate layer, realizing perfection is impossible, and using smart product design and UX to handle failures gracefully, manage expectations, and sometimes just let the human take over.
Exactly. Acknowledging the stochastic nature and designing for it.
It's really clear that even the absolute best systems have limits. They break sometimes. So maybe a final thought for everyone listening. Given this layered view, all these techniques, but also the critical role of product design, how might this change how you approach information retrieval?
Yeah, whether you're actually building one of these systems or maybe just preparing for a meeting about one or even just how you look for information yourself.
How does understanding these layers, these potential failure points, and these solutions change your perspective?
And hopefully the big takeaway is to embrace that empirical approach. Let what's broken in your system or maybe just in your own search process be your guide.
Use the data. Use the failures.
That's the most principled way to improve continuously. And that's where you find the real satisfaction, I think, making information not just findable, but truly useful and accessible.